Weekend. Please mute yourself before the presentation and videos off, please, as well. If you have any questions, feel free to use the chat, and better way would be to save them till Q&A at the end of the session. Okay, so this is the first session. Agenda for today is the first part would be from 2 to 3:30, and we're going to be presenting dynamic structures, battery box interiors, and if you have any questions, feel free to ask them by the end of 3:20 or 4. All right, we can start with dynamics. So I'm just going to pass the presentation to Leif Blake, Dynamics Lead, and yep, are you ready? Great. Okay, so for the team, I'm just going to present. We have Dynamics Leads, and it's Leif, Catherine, Matt, Kevin. You can all ask them questions, and if you have any suggestions or initiatives, feel free to ask them regarding dynamics as well.
Okay. Yeah. So hi, I'm Leif. I'm the Dynamics lead. On the Dynamics team, we're kind of responsible for all the mechanical components that are moving in the car. So that sort of includes the suspension, the steering systems, the braking systems, right now we sort of have everything designed. Everything has sort of been designed for a while, and we've kind of been lingering in a bit of a it's sort of been a lot of delays sort of due to COVID over the past little while. So still sort of our term goal is to be actually assembling all of these dynamic systems. We have a lot of parts that we've had manufactured, and they're kind of sitting in the bay waiting to be put together. There's still sort of some pre-assembly tasks on site. So if you're in Waterloo this term, when we're able to return to our working bay, there's a variety of small tasks. That's some machining tasks, some like making welding jigs and stuff. So if you're interested in that kind of hands-on work, we'd be glad to have you help out. And then also, if you're around sort of later in the term for the actual assembly of the dynamic system, we're going to need hands to put it together, and people who are knowledgeable about the whole braking system. I myself am not in Waterloo physically, so I'll be sort of managing that remotely. We can go to the next slide. I'll just give a short introduction as to kind of the dynamic subsystems and what it's all about. So I'll start off with the suspension. So the suspension of a car is just a mechanism that all right, I'm not sure if it's lagging on my end then. All right. Okay, well, I'll just keep talking and let me know if no one can understand me. The suspension is essentially a mechanism that controls the vertical movement of the wheels. So when you're hitting bumps and stuff, you don't want all of that energy from the bump to be directly translated into the chassis and into your drivers and passengers. So you kind of have essentially a suspension system that reduces the peak sort of force that's exerted. So we have springs which sort of temporarily store energy and then re-release it. And then we also have a damper which actually absorbs some of that energy and transfers it into heat. And so those two, the spring and the damper, work together to sort of protect the drivers. The role of the suspension is also to maximize the amount of contact time between the tires and the road. So when you're driving along and you hit a bump, if your wheels physically jump off of the ground while they're in the air, you can't control the car whatsoever. So keeping the wheels on the ground is quite important. And then it also reduces just vibrations from the road, which is quite uncomfortable for passengers and also can be damaging to other systems within the car. Right, next slide. Yeah, once you have your suspension, which keeps the wheels on the ground, you need to be able to go where you want to go. And for that, we have the steering system. So our steering system is fairly simple. Most vehicles that you've probably driven have like what's called power steering. And so there's actually like either motors or some kind of hydraulic pump that's sort of assisting you to move where you want to go. We don't have any of that. So all of our steering is just based on how much force you can put into the steering wheel. And our system, while that little animation is going up in the top right, that's not actually our vehicle, but that is quite a similar geometry in terms of the steering of our car. So you can see that you sort of have this rack and pinion there, sort of in kind of to the right a bit. There's this mechanism which is essentially just converting the rotational motion of the steering wheel into linear motion, and then there's a series of linkages that then connect to the wheels and turn the wheels back and forth. Yeah, it's fairly, I think, simple to understand in concept. In practice, getting all of the geometry right is quite difficult, and so there was a lot of work put into to getting all of the angles to line up, and hopefully it will assemble properly. And then finally, if we go to the last slide here, we have brakes. So on our car, we have actually two types of brakes. The main brakes for actually stopping the car are hydraulic. So essentially what happens is the driver has a pedal and they push on the pedal, and what that does is it compresses this long tube that's full of brake fluid. And because that fluid is incompressible, hopefully very, very little of the energy that you actually put on the brake pedal goes into compressing the fluid. All of that energy gets transferred along the length of the tubing and goes all the way to your brake calipers, which then essentially are just like a little clamp that just squeezes on a brake rotor and stops the car. Again, this is a nice picture of a brake caliper and a brake rotor. The brake caliper is in red. The brake rotor is the gray disc, which would be rotating, and then the brake caliper stops it. Our brakes are significantly less beefy than this one here. This is something from a much sort of a car that can go a lot faster, so it needs to brake a lot harder. Yeah, I mean, that's basically a quick summary of all the systems. You can see here, so this is actually a picture of MS14. You can see that you kind of have the wheel there, which is just shown with a rim here. There's no actual tire on here in this CAD, but the wheel connects to a bunch of suspension components, and then suspension connects to the steering, and then the brakes are shown in there. You can see the calipers perhaps sort of tucked inside the rim, and those are just connected not through linkages or anything, but just through hydraulic pressure back to the driver. This is the front suspension, and then the rear suspension is a lot simpler because you don't have any steering on the rear. Yeah, so as I mentioned, we need to just finalize our plans. A lot of that is just going to be in terms of making sure that the people who are on site and ready to assemble it are very familiar with the system and familiar with how it needs to go together. And then there's also a few miscellaneous on-site tasks that need to happen before we can assemble the suspension. And that's all for myself. I think the next slide is a bit of this is some of the supplier interfacing stuff. I don't think that this is particularly relevant anymore to Dynamics. We still have a few relationships with companies. A large part of what we've had to do over the past couple of years is obviously is sort of interfacing with machine shops and lots of people who are able to make stuff for us and to get surface finishes on parts. But a lot of that is kind of done. There will still every now and again be a few small things where we need to communicate with a company. So this is just something to keep in mind. If you're working on Dynamics, you may also have to, or it may be part of what you're doing is to communicate with companies as well, which is both a good skill for working in the real workforce and also quite vital to our team. And yeah, if you have any questions about Dynamics, feel free to ask them now.
All right, thank you, Leif. Anyone has any questions?
Yeah, so we've done all of our design in SolidWorks. And then in the past, we've also done some finite element analysis. So basically verifying the strength of all the individual components. We've done some of that in SolidWorks as well as through the software called ANSYS, which is a sort of a simulation package. But all of the design work was done in SolidWorks for Dynamics, yes.
We're just going to give it a couple of minutes for the questions to flow. If you come up with any questions later on, you can always feel free to ask them in the chat.
So this slide is just some onboarding information for everyone. So, oh no, this one wasn't changed. So since most of you guys are on Slack, please join the MEC class of spring. So S 2021, not fall 2020. There we'll have a lot of updates and like direct you to where our channels are. So if you guys are interested in Dynamics, for example, like Leif just presented, or like other sub teams, this is where you would go to, especially as a new member. And if you want to start learning more about the car, you can check out this link. Next slide. I think there's more for onboarding. So for Dynamics specifically, we share sub-team check-ins. So sub-team check-ins are like weekly or bi-weekly sessions where we just kind of go over the projects, announce any major announcements, and kind of check in where each project is at. We share it with structures, and this happens on Wednesdays at 8 p.m. on Zoom. The link will be sent to Mechanical, and Saturdays at 1 p.m. on Zoom as well. And on the last slide, one more next step. So Dynamics is part of a like MEC general training type of series. So it's like a 3-week-long type of training session where you go through a project through like drawing, simulations, etc. So we will be having a training session at 4 p.m. So at the end of this 101, we will have some information about what these training sessions are and a bit of information of the first one. So stay tuned for that. That should be wrapping up Dynamics.
All right. Thank you, Catherine. We can now go for Structures 101 with Tommy, Kimberly, then Michael, and Catherine. All right. I'm just going to pass presentation to Leeds again.
Yasmin, could you present the slides again? Because I think we updated some small changes. Yeah, and then I guess you can just go to the beginning slide or whichever one you were at. I think one back or two back.
Oops.
Yep, okay, that's great. All right. Hello, my name is Tommy, and I guess I'm structures lead. I'm currently in 3A mechanical engineering. I'm on my study term.
Hello, I'm Kimberly. I'm the chassis lead, and I'm also in 3A Mech this term.
Yes. Hello.
Yeah, we hear you.
Epic. My name is Min. I'm in my 2B of mechatronics, and I'm the current aero body lead.
Hi, I'm Michael. I'm the assistant aero body lead, and I just finished my 1B nanotech eng, and I'm on co-op right now.
Cool. And then we also have Catherine, who has spoke previously, but she's the project manager for structures also. I guess you can go to the next slide.
Yeah, so structures is made up of two parts, an aero body and a chassis. And like I mentioned, I was the aero body lead. So the aero body is basically the entire exterior of the car, so all of the body work. And the geometry was finalized a while ago by previous leads, and they did a lot of fluid dynamics and stuff like that to finalize it. And currently, right now, we're just in the process of actually, I guess, turning that dream into a reality is a fancy way to put it. So it's a lot of composites manufacturing, primarily with carbon fiber, as well as some thermoforming for our windshield and all of our clear panels, essentially. Yeah.
Yeah, so the other half of structures is chassis, and the chassis has two main functions with respect to the overall vehicle. So first, it provides the main structural integrity for the car. And then second, it also serves as a mounting point for many of the other sub-assemblies within the vehicle, such as dynamics, air body, and interiors. So on the left here, you can see the chassis welding jig, which is the darker extrusions there. And that was a project that was complete in the fall. So currently we do have the overall frame of the chassis welded. And this term, basically the goal is to implement some of the other smaller components. Yeah, so if you're interested in doing some on-site work, there's definitely opportunities for that.
Cool. And I guess this is just like a quick overview of what types of projects we're running this term, or what you can think of as what is left to be done for the car. And I guess just to read through it, there's resin fusion and manufacture roof panel, which kind of goes under aero body panel manufacturing, which is an on-site task. There's also material testing, which we'll talk about more afterwards. But that is also an on-site and remote task. Well, I guess each project has a remote and on-site task because there's always some aspect of research. And then there are some, as Kimberly mentioned, some on-site aspects for the chassis as well. And so there's like a large majority of on-site work to actually manufacture and deliver the physical product of the vehicle, so that we're trying to transfer CAD model into real life object for us to touch and drive. Yep. And then here, I guess like our goal for this term, would be referred to as rolling chassis, which kind of includes what you see in this picture. We're trying to assemble what's here, such as some dynamics assembly. I think most of the dynamics assembly actually, and then the BOM panel. And we have the chassis already welded. And there are some other logistics surrounded around there, but this is the general goal we're kind of working towards.
Cool. So I guess I can talk about the first kind of overarching project that the Aerobody team is going to be working on. So this is an on-site. Well, I guess there's both. Like Tommy said, there's lots of intertwining between remote and on-site tasks, but the majority of this will be on-site in Waterloo. So what this task or project basically entails is that we've been using a different manufacturing technique for carbon fiber for quite a while now, and we're starting to shift our focus to try another technique called resin infusion. And basically what that entails is we're going to need to do a lot of our own like test pieces and testing in general, just in order to kind of set to understand the limits of our manufacturability, because everything you read online is usually a bit more optimistic, and most people in industry have better equipment than we do. So we need to kind of self-define our own limits of manufacturing, if that makes sense. So I guess the steps for that, we're currently in phase 1, which is just like research and documentation. We're trying to gather all of the knowledge that we can while we're not allowed in the Bay. And then once we finish that, then we need to make a manufacturing plan. So basically just detailing out what exactly needs to be done once we get on site. And then come June 2nd, hopefully, if the lockdown isn't extended, we'll be able to start doing test pieces. So there's a picture in the bottom right corner, which is a lot of old Midnight Sun 12 leads doing the same process. And so we'll be doing something similar to that. And then lastly, once we've set up our own parameters, or like once we understand the limits of our in-house manufacturing, then we're able to do some of our actual car panels, like the roof and the hood, which are highlighted in blue on the right. Yeah, so for next steps in terms of this, I would probably just say come out to the Aerobody onboarding, and feel free to reach out to myself or Renzo, who's the interiors lead, over Slack. Right, I'm still here. Nice. Okay, this is our second main project for Aero. And it's basically we want to manufacture the roof panel. Now, typically we would, one panel would be like a third of our term goals. But what makes this panel special is that we're trying to use a new molding technique. We're basically using sheet metal as opposed to any foams or MDF, which is just a type of wood. And so with this, it comes some like design challenges, and it's a concept that's new to Midnight Sun. Yeah, and so the basics of it is that you use these ribs that are at the bottom to basically dictate the geometry of your top surface of the mold, which is that big sheet that's sitting on top of the vertical pieces. Yeah, this is kind of a technique that we've been trying to develop under the guidance from ETS Polytechnic, which is a school in Montreal. Yeah. In terms of next steps, I think it's pretty similar. Coming out to the Aerobody onboarding, as well as just reaching out to myself.
My turn. So my main project here for this term is the floor panels. And again, the goal is to finish. We are very much in the last stages of manufacturing. We just have to do our final preparations, and then as soon as we get back on site, it's going to be one of the first things that we do in terms of composites manufacturing. So if you see in bold, if you want to get hands-on experience fast, this project's for you. So on the right, you kind of see where the floor panels will sit. They're just flush with the chassis. There's also a special part about the floor panels is we have to integrate it with the seats. So we have to strategically plan cutouts for certain parts of the seats and give enough space for physical fastening for the seats to be bolted to the chassis. And then hopefully, if all goes well, then we will be able to integrate it with the chassis. And yeah, so make sure to just reach out to me or Min whenever. Yeah, I'm always open to answering questions about this kind of stuff.
Yeah, so the next project is Aero Chassis Integration. And this project basically deals with the installation of all the composite body panels onto the vehicle. Currently, all the projects are remote because we're in the design and planning stage. So key steps for this project. So first, everyone goes through a research and concept development stage where they take a look at the existing CAD and figure out what kind of mounting method would work best for that panel. And then after that, they would do some CAD design and fixture design just to make sure that everything fits properly and there's no interference. It would also require doing some calculations in FEA. So as you can see there, that's one of the tabs that we're planning to use for the roof panel integration. So we would need to validate some loading conditions for that. And then another really critical aspect to these projects are the manufacturing plans. So since we're going to be carrying out this integration on site ourselves, it's really important that we are creating designs that will work for us and that isn't too difficult to put together. So being able to design these things that, being able to design mounts that are manufacturable in-house and things that we can assemble are really important. And so you can see there's a list of some ongoing projects. We have the roof panel, side panel, bridges, hood, and windshield. And the goal for this term is to be able to complete all the planning and designs, basically all the remote stages of this project, so that we have those ready to go once we are allowed back on site and once all the aero panels have been manufactured so that we can easily transition into the manufacturing stage for this project.
Hello, it's me, Tommy. So here I'd like to talk about the material testing project. The term goal for this is mostly to complete the general testing related to the car. And what I mean by general would be elements that repeatedly show up on the car. So that would include like composite panels, adhesive joints. Those are the common ones. So if you have like a general procedure, you can just copy and paste them for each individual panel that we have. But anyways, in terms of kind of what you kind of get out of this project is, I guess, how we kind of approach finishing this, I guess. Okay, so like the first step would have to do with like researching and doing a test plan. Secondly, we would have to do on-site testing. Thirdly, we'd also like to do some simulation to see how similarly the actual pieces perform and how we kind of hope for them to perform based on design. And then lastly, it would be like writing a test report so that we can calculate and share our results. And I guess the best way for you to really get an idea of what that means or like what this process is like, it's very similar to like a lab that you do during your courses. We're basically trying to be professors or TAs and trying to set up these labs so that we can run them and then write a proper report related to them. And I guess on the very right here, I tried to talk about what type of skills you specifically develop. And I guess it's kind of like the sense of quality assurance where you create design, but then you probably want some type of procedure or method for you to validate that your design will actually work. And so the material testing project is a means for us to come up with the logical way for us to properly validate our designs, and specifically towards like the mechanical team, it relates to like how strong it is, or like how well the material properties are after the components are manufactured. And then I guess lastly, this project, I'm also looking to open it up as like a general QA resource, in the sense that it's supposed to help other design projects that might be taking place. And here at the bottom right, I just included pictures of the seats and like some other interior components. And I guess like looking at the examples of these pictures, you might guess that there are different ways that you can implement these objects into the vehicle. And some of those methods might be more reliable than others. And so what we would do as the material testing project team would be, I guess, talking to the designers and trying to help them out with how we can create experiments or replicate experiments that can help us get test results in terms of performance. So I guess like what the designer does is that they can put it in CAD, like SolidWorks, and then run simulations, and then they get numbers on their screen. And then what we do to help them is we run actual experiments so that we get actual test results to see how far off it is from the actual design. And that's very useful when what you're designing with is a very inconsistent material. And so that can relate to composites and adhesives. Those things can perform better or worse based on how good your manufacturing process is. And you wouldn't really know how good your manufacturing process is until you make and break your actual part. There's no testing for metal items in here, just because metals is very well researched and their failure behaviors are very predictable. But aside from that, we are very much a resource that helps with interesting design projects in general. And I guess like I would be the person to message if you have any questions or interests related to this project. Thank you. So I guess this slide and also the next slide is basically just telling you to join Slack. And we also have a Confluence page. I think it's better if we go to the next slide. We share the MEC general meetings on Wednesdays and Saturdays along with Dynamics. And then if you go to the next slide, for the training in terms of the projects that were mentioned during this section for structures, first of all, there's a lot of composites training or one-on-one sessions related to aerobody and interiors. So that's something that you can most likely look out for. And then in terms of the material testing project, I'll be holding like a training session on this date and time, which I'll mention again in the future. And that's just based on whatever needs of training we would need in the future. But I think for the most part, if you join our Slack and join the Confluence and also show up to the MEC general meetings, we should be mentioning the composite training sessions and the material testing training sessions. That's all from me, unless someone else has anything else to say. Oh, wait, I remember now. Okay. The other valuable thing that you might want to do as part of your onboarding process is probably complete the MEC general onboarding project. The reason why you want to do that project is because we might not always have an available task for you to finish to get you like used to the process. And so I guess it's easiest for us to give you a simple problem for you to solve and then slowly understand how our team works. So please finish that project first before you start investing too much in other tasks.
All right. Sorry, my Teams is a bit weird. I have to get back to it. But we can start with Battery Box if anyone doesn't have any questions. Okay. So battery box going to be led by Makai and Owen. And if you are ready, we can start.
All right. Hey, everybody. Welcome to the Battery Box one-on-one for 101. So an introduction to the team. Michael Black is the Battery Box lead, and me, I'm the Battery Box PM.
You can take this one too, Owen, if you want.
Oh, okay, sure.
Just the intro.
So, yeah, just some term goals for the team. We're going to finalize the CAD of the battery box. And once we're back on site, we'll continue module manufacturing, manufacturing the battery pack, and also assembling the module and pack. And some of the projects that we'll be working on are mounting, wiring, isolation, documentation, and also some design for 3D printing. Okay,
Cool.
next slide.
So the battery box in the car is one of the most important components, in my opinion, at least, my humble opinion. It provides a source of energy storage in the car in order to be able to run our motors and store the energy that we collect from the solar panels. Although putting all this energy inside a box can be dangerous, there are definitely safety concerns that we need to pay attention to, such as thermal runaway or explosions. We are dealing with high voltage inside the battery pack. So I'll talk through a few safety concerns with it later. There's the reliability that we need to consider. We need this battery pack to be able to run reliably throughout all our testing and throughout the competitions. As well, we need to be able to make it manufacturable. A lot of the other teams have been talking about manufacturing methods, and that's no different for us. We need to be able to manufacture the battery pack, and a lot of equipment is sometimes fairly specialized for battery pack manufacturing. And because of that, it's sometimes expensive. So we have to come up with other ways of doing that, such as spot welding is one consideration that we've had in the past. That's fairly different than most other manufacturing methods that you sometimes see for batteries. On the right side, you can see a picture of the electrical boxes inside our car. This has changed a little bit. This is kind of an old diagram, but to give you a general idea, our battery box is going to sit in the middle between the front passengers, and then we'll have a rear electronics enclosure between the rear passengers. And then our motor controllers and motors will be in the rear of the vehicle behind the passengers. And we'll have other electronics boards up at the front of the car as well that have the driver controls and some more front power distribution for the lights and other items like that. We can head to the next slide. So for the battery pack, it's split up into 3 levels of energy storage. And at least that's the simplest way that I can think to present it. There's the cell level, and that's the smallest unit of energy storage that you can purchase from the manufacturer. And some of you may have heard the terms 18650 or 2170, or maybe now Tesla's 4680 batteries. But this is the smallest unit of storage that you can get from the manufacturer. For our car, we're using 18650 style battery cells, and we purchased them from, as we're using the LG MJ1 style or model, which are fairly high capacity and high energy density. And I'll get into those terms a bit later. But then once you assemble all the modules, or all the cells, you put them together into what's called the module. And that's going to be the smallest removable unit inside your battery pack. So in our modules, we have 50 cells in each one. And we attach it to the car with 6 bolts for the mechanical and electrical connection to the other modules in the battery pack. And then once we have all our modules assembled together, then it's called a pack. We have 18 modules in our battery pack, and that makes up all 11 kilowatt hours of this battery storage in Midnight Sun 14. And yeah, that is the 3 levels, so cell, module, pack, and there's many considerations for each one as you're selecting the cells and as you're putting them together into modules. You kind of want to balance between, if one cell fails, you don't want to have to replace your whole pack. So you want to split it up into modules, but you also don't want to have modules that are too small that you're making 30,000 modules. We wouldn't make 30,000 modules, but just as an example. So we've chosen middle ground of around 50 cells per module, so that if one cell fails, we can replace the module without having to replace the whole battery pack. You can head to the next slide. So we'll get a bit more to inside the cells now. These might seem like a bunch of complicated diagrams, and you don't necessarily need to understand them all, but it's good to know at least at a high level what's going on inside the cells. The first thing to point out is that battery cells are not electrical energy storage devices. They are chemical energy storage devices. And they do that by storing ions on either the cathode or the anode side. And by pushing those from one side to the other, then it forces electrons to go through the circuit, as you can see in the top diagram here. And those electrons going through the circuit is a current that's flowing, which you can get your electrical energy from. One important part of the battery pack is obviously characterizing the cells to make sure that they're not going to heat up, and make sure that you understand them well. So one model that we use for that that's fairly popular is the Randall's model. That's in the bottom center of your screen there. So it's just a combination of a voltage source and a resistance that's in series, and a few other resistance and capacitance items that will also affect the total output voltage and output power and output efficiency of the battery pack. So we've done some characterization on our cells to determine these parameters in order to create a better model of our pack, and thus we can ensure that it's going to operate safely. And the last thing to be aware of is the mechanical construction. The cells are created in essentially a steel can, and inside there's a roll of your anode and the cathode and a separator. As you can see in the image in the top center of your screen, there's the cathode and a separator in the anode. And then you can see those rolled up inside the cutaway diagram on the right side. There's a positive electrode, the negative electrode, those are the cathode and the anode, and the separator, which separates the two as they're rolled together. If there's ever a short circuit between the cathode and the anode, so if you connect them directly, then that will create a lot of current flow, which creates a lot of heat, and that will destroy the cells. And we'll get into what actually happens when that goes on the next slide. If you could head to the next slide, that'd be great. Cool. So when you get an internal short circuit connecting the cathode and the anode together, that's what's called an internal short. And there's a lot of current that flows through that, which creates a lot of heat. And then that heat will obviously raise the temperature of the cell, and it will create other reactions inside the cell. There's a few terms here that you may or may not recognize from chemistry, but there's a secondary reaction that happens inside the cell when it gets up to a high enough temperature. So as you heat it up, the cell has on average more energy, more thermal energy, and that means that this secondary reaction, which typically has a high activation energy, now is closer to that activation energy. And then that reaction is exothermic, which propagates everything. Basically, if your cells heats up, it's not going to stop heating up until it's completely destroyed. So you want to make sure to keep the cells very cool so that they're far away from that activation energy point of that second exothermic reaction. And one term that you'll hear is thermal runaway propagation. That's when thermal runaway, this internal short circuit and high temperature of one cell, will cause thermal runaway in a second cell. So as it heats up, then the cell will possibly explode, and it will cause cells that are beside it to also get fairly hot. And then that is called thermal runaway propagation if those cells then explode and the whole battery pack can explode, which is not fun. And you can see here on the bottom some images of one lithium battery fire and another one in the center. that's of a solar car that had a battery fire with the World Solar Challenge last year, and there's not much left of it. So we don't want that to happen. We want to design a safe battery pack, so we need to properly understand our cells and design our cooling system appropriately. And last point is we're also dealing with high voltage here. Our battery pack will run at 150 volts DC, which is more than enough to kill you. So there are multiple safety rules that we have in place when we're working with the fully assembled battery pack at high voltage in order to make sure that everything is safe. You can head to the next slide. So onto the cooling system a little bit more. Everything produces heat during normal operation. It's not just thermal events that will create the heat. So as we're cruising down the highway or through testing, the batteries are going to generate heat. And that is partially due to the internal resistance inside the cell. If you remember the Randall's model from a few slides back, there is a RS, the series resistance. That will create heat as current flows across it. So we've done some thermal testing on our prototype battery modules, and we've come up with some results. Based on those results, we've been able to design what we consider to be an adequate cooling system. We still have to test it once the whole pack is assembled. We did our testing on one module, and we need to verify that testing on one module is going to be valid when we have all 18 modules in the pack. We're obviously producing more heat when we have 18 modules, so we want to be able to ensure we can cool 18 modules appropriately. So you can see on the bottom right the test setup that we use to test a single module. So we've got an electronic load, which we use to draw current from the battery module. And then we have a few power supplies that we use to charge it back up. And then we connected it all to a computer to log the temperature as we were discharging the battery module. And from that data, we were able to create this temperature map inside the battery module. And you can see that in the center, this is kind of like a top-down view of the battery module. In the center, it doesn't seem like there is much cooling happening in there. So what we use this data for is then we redesigned the battery module and created some extra cooling channels in the center in order to keep those cells cooler. So using results from testing in order to make your designs better is always a great thing. Iterative design is awesome. You should always be doing it. But yeah, that's one example of what we've done in the past, and we hope to continue doing that in the future with future battery pack designs as well as for this pack design and continue the testing. So you can go on to the next slide. This is kind of jumping around a bit here, so if you have any questions, just let me know. I'm just trying to cover a bunch of terms that you'll often hear so you aren't super confused when you jump into a battery team. You'll often hear the term a balanced battery pack, and so I'll try and explain that a bit here. Each cell will have different characteristics. So some cells might be able to hold more energy than another cell. And that's true even within the same manufacturing batch of the same model. There's always variation in any manufacturing process. So we want to ensure that all of our cells have the same energy capacity, or at least have some way of dealing with cells that might have a different amount of energy storage. But the problem with having cells at different levels of energy storage, or that can store different amounts of energy, is that as you charge it up, cells that store a lower amount of energy are going to charge faster, and they're going to reach full charge first. And full charge will be a 4.2 volt cell. And we don't want to exceed that, as higher voltages will cause extra stress on the crystal structure inside the cells, which will lead to internal shorts quicker. But we're limited to a maximum voltage, so those cells that have lower capacity, lower energy storage, will charge up faster and reach that voltage. And that means that there's lots of energy storage that we could be using in the other cells that we aren't able to use because we have some cells that are not balanced with the rest of the modules. So it's having a balanced pack where all the cells have the exact same amount of energy storage is desirable so that we can use the full range of the battery pack. as well as that these cells that are charging fully and then discharging fully, the ones with lower capacity, will be essentially used more. They'll have more of their total range used, and batteries don't like being at their total maximum voltage and minimum voltage as long as they do in the middle range. So those cells are going to degrade quicker than the rest of them. So it's great for safety, great for storage, and great for reliability. Let's go ahead to the next slide. Cool. And obviously the battery pack is a fairly complicated piece of design, as with all the other designs on the team. There's multiple different design techniques that we use to do it. It's a little bit of a unique challenge given that we're manufacturing 18 battery modules, and most of the other parts in the car we're just making 1 or 2. So through the module design, we've thought a lot about how we're actually going to manufacture it and assemble it. So we use lots of techniques for like different like low volume manufacturing stuff. So 3D printing, laser cutting, water jet cutting, CNC machining. We've done each of those on this battery pack design. And moving forward, we are going to be designing the rest of the battery pack mounts, and lots of those are going to be 3D printed. Yeah. So thanks for listening. If you have any questions, that would be a great time to ask them.
Okay, so if you're interested in joining BatteryBox, first off, you'll want to join the Slack. That's Mech BatteryBox, and then as well, you can read up on more about battery basics with the Confluence pages. So the battery basics page will go over more about how batteries work, the chemistry behind it. And then battery module Rev 5 is a slideshow that goes over all the components of the battery modules. Next slide, please. And our weekly check-ins are every Thursday at 7:30 p.m. on Zoom, and there will be a link sent in Slack a day before or the morning of that day. And on those days, we'll go over task updates, and then Michael will be available to answer any questions. And then as well, we have an offline intro project for new members, and that'll be going over how to design a battery pack. And we'll be doing that for the first 3 check-ins of the new term. Next slide. And yeah, same with the other teams. You'll want to join the Mech class spring 2021. And as well, if you want to learn more about the car, you can always read on Confluence about those. And yeah, just to repeat again, the intro project, it'll be 3 weeks starting from the next check-in, and you'll learn the basics of how batteries function and how to design a battery pack for a car. And you can ask questions over DM to Mike and I or during check-ins.
All right. Anyone has any questions? All right, we're just going to move on to interiors. And if anyone still has any questions, again, feel free to use the chat. So interiors 101, we have Renzo, Ali, and Sheila. If you can introduce yourselves.
Yeah. Hey, everybody. My name is Renzo. I am one of the interiors leads. I'm currently just starting my 3A term mechanical. And yeah, excited to be presenting this 101. Ali?
So, sorry, I'm outside. I had to join from my phone. So I'm Ali. I'm in my 2A Tron term. Sorry, that's my neighbor. I'm in my 2A. I just did my 2A Tron term. I'll be doing 2B in fall. I recently started as a co-lead with Renzo for interiors. And yeah, I'm looking forward to the term. And Shayla?
Hi, I'm Sheila. I just finished my 3A term, so I'm in my co-op term right now, and it's my first time doing the interiors PM, so hoping it goes well. Yeah.
Okay. So what is the purpose of interiors? So yeah, well, our mission is to, as it says here, win on all fronts in terms of efficiency, reliability, and practicality. However, just like the main mission of Midnight Sun as a whole is to focus on team member development and make sure everyone who's part of interiors or like the whole team has the opportunity to improve their skills and be the best, I guess they can be. Yes, Interiors is quite a new team. The past cars that Midnight Sun has produced all did not have a dedicated interiors team or plan. Since those cars have only been mostly one-seater, with the exception of our previous car, MS-12, which was a two-seater. But even for that car, the interior wasn't emphasized as much as we are emphasizing it for MS-14. So yeah, there's that image there that was made like a while back, but that was one of the concepts for the interior. So yeah, that's what we're trying to work towards for this car. Next slide, please. Yep. Oh, I also forgot to mention that this team is very diverse. So we have a bunch of people from different programs, different faculties even, and skill sets. So it's a very, very wide range of interests and skills on this team. So yeah, what do we do? So interiors is also a part of mechanical, but what we do is everything that is not also the part of the mechanical system. So anything that's inside of the car that interacts with the users, that is all our domain. So everything from ergonomics to ventilation to material selection, aesthetics, composites manufacturing. If you were here when during the aero session, then aero and interiors will be working together quite a bit because a lot of our manufacturing plans are going to overlap. So we're going to be merging our powers for this term. So yeah, that's basically what we do. Next slide. Okay, big question. Why do we need an interiors team, or why even have one? It's pretty straightforward. Like if the people who are sitting in your car aren't comfortable in it, then it's not really a car. It's just like a showpiece, right? And so, yeah, that is probably the biggest reason why we're emphasizing interior design for MS-12 or MS-14, sorry. As you can see in the left image there, that was a photo from the interior of MS-12, so the previous car. Apologies if it looks very messy. This was after competition when they were taking it down. So it looked cleaner than that. But this interior was put together like very last minute. And so there's not much planning done beforehand. And as you can see, you can see bits of chassis, bits of wires, and other things that would normally be covered up in a commercial car. And so that basically is our goal for MS-14, is to build on this first trial that MS-12 had and make it even better so that it would look more like something on the right, which is Eindhoven's car. So they're a team, solar car team in the Netherlands, and they basically have been winning everything recently. So, and you can see why, because like their car is pretty sleek, and they've also put a lot of effort and emphasis on their interior because it actually looks like something you want to sit in. So yeah, that is sort of the main main goal we're trying to strive towards with this car. Next slide. So yeah, it's very important. How will we help MS14 be the best team in North America? So this little equation here is how the scoring is going to be done for the ASC. So S is total score, D person mile distance, E total external energy, P practicality, and then C completion factor. Interiors itself is mainly or completely responsible for the P variable, so practicality. And so that basically entails, yeah, how attractive and reliable the interior is. Like, does it make people want to sit in it? Is it comfortable for people sitting in it? And like everything like that. So, and as you can see here in this equation, the P is a multiplier for the total score. So our goal basically is to get that variable as high as possible so that the overall score is increased. Next slide. Oh yeah, so the breakdown for practicality is, I should also say that the practicality score itself is it's probably the most subjective of the scoring. Yeah, it's probably the most subjective score of the entire competition, because you can't really put hard metrics on how comfy are the seats, right? So this is just a general outline that was given by a WSC, so World Solo Challenge. So we have here cabin space and comfort features. So yeah, what features would you have that make it resemble a regular car? Ease of use. Is it intuitive? Are people getting frustrated when they're touching the buttons and all that? And then desirability. Basically, how pretty is it? Will people want to be inside the car? And then you have driving, which is not our, we're not dealing with that. And then storage, obviously. And then I should say too that these metrics are or probably will be open to change, and it's all up to the scrutineers. I don't want to say opinion, but like what they want to emphasize, they'll score on. So this might not be the final rubric, for lack of a better word. Yes. So next slide. Sweet. So interiors is very spread out in that we are dealing with projects that interface with both mechanical and electrical as well. So if you decide to join this team, then you'll get a lot of opportunities to communicate with different people on different sub-teams to get more knowledge for whatever project you're working on. And so, yeah, as you can see here, our project list is very split down the middle in terms of manufacturing and design. So for this term specifically, and sorry, that should not say fall projects, that is spring projects. That's my bad. So yeah, manufacturing is the catamaran cover, the seats, and the doors. So I'll give a brief rundown on catamaran cover. So basically, yes, if you were listening to Michael Black and Owen, their talk previously, this will house the battery pack and all the accompanying electronics in the car. It will be a fiberglass enclosure, full fiberglass enclosure, which will sit down the middle of the car on the catamaran, which is the shape of this car sort of resembles a catamaran boat where there's like a giant empty space down the middle. And so this will sit on top of those chassis tubes that go down the center of the car. And basically, yes, this is a pretty a support project to Battery Box, in that the main goals here are safety and yes, safety is number one. And so yes, minimizing the risk of thermal runaway, or even minimizing the damage of thermal runaway should that happen, which we are trying so hard not to make happen. So yeah, that is catamaran cover, and this project is nearing completion, and that design phase is already locked down, and we are transitioning to manufacturing once the campus opens up. Sheila, do you want to talk a bit about seats?
Sure, yeah. So Seats is in a very similar position in terms of manufacturing. I don't know if I need to explain what Seats are. Basically, this is the first time the team has decided to manufacture our own seats. We basically decided to do it because it's very hard to get the size and the angle of seats that we need because the car is very low and the seating angle isn't necessarily accommodated by like an off-the-shelf kind of market seat. So we decided to build our own. They're going to be also composites manufacturing, so we're going to be doing some carbon fiber with a core. So the team is going to be trying to do infusion this term. So hopefully we get to learn with Aerobody on how to do that sort of manufacturing process. What else? We're kind of accommodating the design as the car evolves. Just a little bit tweaks, but the main design component is completed. And we hopefully can manufacture this term, maybe like at least start. But yeah, we're super excited. So come join us. We're always happy to have some more people to help with manufacturing.
Sweet. Oh, sorry, go back. Thank you. Okay, so that was seats. And then the third project is doors. So doors is, yes, self-explanatory. We will be mainly focusing on the interior side of the door. So the exterior door panel that is in Aerobody's territory. So they will be dealing with the manufacturing of that. What interiors we'll be working on is mainly the hinges, latches, and then the cosmetic interior door panels. Yeah, this image on the bottom right is pretty outdated. Yes, the current design has changed a bit, but this is generally what we're working on. And so, yes, the things about this project, this will mainly interface with any mechanical, so there won't be any electrical systems in the doors per se. But yes, this will also contain a lot of composites manufacturing, some sheet metal design, 3D printing also. So yeah, that is another one that we're hopefully trying to at least get some progress on this term. So yeah, that's it for manufacturing. For design, we have a dashboard. Ali, do you want to talk about that?
So basically for design, it's the dashboard, trim, and steering wheel. So all three of those, especially trim and especially steering wheel, they're basically in the design stages right now. So we're still mocking up the actual detailed designs of each of the components. So the past term I've been working on the dashboard. So essentially it's a molded composite piece that will be manufactured in the coming terms. So right now we're basically trying to integrate all of the electrical components, the steering columns, the catamaran cover. There's a lot of components that basically dictate how the design of the dashboard will eventually be. So that's why it's a lot more in the it's really important in terms of how we design it, because there's a lot of potential spaces where there could be interferences, there could be things that don't actually fit. So essentially, if anyone's interested in learning SolidWorks, or is already good at working with surface modeling, I would definitely recommend checking out interiors. So some of the components that within the interiors, sorry, the dashboard, I should say, within the dashboard project includes the screen mount solutions, the internal support structures of the dashboard, the ventilation system that goes into the dashboard. So there's a lot of things that will be need to be completely detailed designed this term. And for trim and steering wheel, did you want to speak, or should I, Renzo?
I can take it over. So yeah, trim is the basically, yeah, it's almost purely aesthetic. It's any miscellaneous component that will be used to either cover up parts that we don't want to see or just make the whole interior feel more comfortable and commercialized, I guess. So that's things such as ceiling liner, any other interior composite panels that are non-structural, fabrics even. So yes, there's going to be some material selection in this project as well. So yeah, that's basically trim. And then steering wheel is also self-explanatory. This would be a smaller project in itself, but still very important because it's a steering wheel. Yes, and this will also be similar to your dashboard and even Catamaran cover. You'll be communicating a lot with the Dynamics team and the electrical team, because the steering wheel integrates with the steering column and the tilt mechanism, as well as there are going to be buttons and also the steering stock that will involve electricals. And so, yes, the image on the right is a working concept for the steering wheel. But yeah, that's pretty much all our projects. Next slide. Sheila, do you want to explain this?
Sure. Yeah, so I guess basically those are our main things that we're using. Slack is for communication. Confluence is all our documentation. So anything you want to find out about interiors, we're trying to document. So if that's research that we've done or any sort of fasteners, we have a little bit of composite research, and then just, I guess in general, there's a couple of design logs in there and process of design for all of our projects. Yeah, so check that out if you're interested. I think it gives like a good overview of kind of where the projects are and how they came to be at that kind of point. We use a lot of SolidWorks, as probably you can infer. So right now, seats, at least I can speak to seats, we are in the FEA process. So we are doing a lot of simulations and a lot of hand calculations for side collisions and rear collisions and any sort of other ballast flying through the air, any sort of, or like person flying through the air, just like making sure that the person is safe, because that's super important. Yeah, and sort of we have a lot of the other projects that are in the design stages will be obviously designed in SolidWorks. And then GrabCAD is where you're gonna connect to SolidWorks and find all the files. I don't know if I missed anything.
No, that's pretty much it. Yeah, that was all our resources right there. Next slide. Yes, next steps. Okay, so yes, just like with all the other sub teams, you can add the calendar, which is solar@uwmidsun.com. Yes, get acquainted with our tools if you're a keener, and you just want to learn more. So yes, like Jill said, Confluence and Slack, join our channels, and then if you'd like, just like peruse all our documentation if you want to get familiar with it. And then weekly interiors meetings will be Wednesday, 7:30. So right after the Midnight Sun general meeting. And our meeting will last like 30, 40 minutes max. And then also very important, there will be no interior specific onboarding session. So we will be joining forces with the general mechanical team as well. So if you're interested in interiors, you will still have to complete the general mech onboarding project. So yes, look forward to that. I believe this is the last slide. Yes. Any questions?
if you do end up having any questions, feel free to like Slack us or Slack the Mech Interior channel, and we will answer very happily. Please ask.
The onboarding.
Yeah, so hey guys, for those of you who don't know me, my name's Yan Shan, and this term, Aiden and I will be supervising the onboarding project for all new members of the mechanical team, as well as returning members who kind of just want to touch upon their skills. And so this project will basically allow you to practice your SolidWorks modeling skills, as well as some simulation skills, and kind of how to keep track of all your work in the form of a design log. And so our first session will actually be today at 4 p.m. I'll be sending a link out in the mechanical Slack channel, so make sure to join that. And basically, we will be explaining each stage of the project in more detail, as well as going over how to create a design log in order to keep track of all your work. And at the end of this session, we will kind of assign your task, which will be to create a basic part in SolidWorks. And so the following week on May 18th, we'll kind of go over that part, and then we will assign in a simulations task, which is basically an FEA in SolidWorks that will on the same part that you created previously. And then later that week, we'll go over the FEA, and then assign a design task, which is more open-ended. It'll basically be, you'll realize from your FEA that the part cannot support the applied force, and so you'll have to make your own decisions and come up with a modified part that will end up satisfying these applied load. And so we'll give you a week to do that, where you can kind of catch up and kind of get as much done as possible. And then the following Wednesday on June 2nd, it'll be kind of the last session where we will review kind of all the work you've done so far and your design log, and give some tips on how to kind of improve your documentation process to make it easier to read. And yeah, and so by the end of the project, you should be able to, you should feel much more confident in kind of participating in all the projects that are happening in Midnight Sun.
I think there's a question.
Yeah, okay. Okay, what do we do if we do not have SolidWorks? Okay, so Catherine just answered that in the chat.
Okay, great.
So yeah.
Thank you. For any questions, again, you can ask the chat always, and we'll respond within the chat or during the presentation. As for now, we're going to move on to the new section with a half-an-hour break. And at 4 p.m., we're going to start with hardware, firmware, strategy, and business. So feel free to have a break and return if you're interested. Thank you for coming, and I'm gonna stop sharing the screen.